Hello my dear students, welcome back to NEET World. So today in this session we will be discussing the IPE questions that is related to second year metallurgy topic. Okay, so from this chapter, from General Principles of Metallurgy, we can expect 4 marks questions in your IPE final exam, right? So let us see what are the questions they are going to ask, okay, along with their answer explanation also here. See, the first question says, explain the purification of sulfide ore by froth flotation. Okay, so what they are saying? So explain the purification of sulfide ore by froth flotation. What do we mean by froth here? See, froth it is nothing but, see, something like a foam. When we are using like detergent, what we will be seeing? Some kind of foam will be coming now. So similar to that, here we will be having something called froth here. Okay, so now this froth flotation is a technique used for purification of sulfide ores. Okay, remember this, it will be useful for your competitive exams like EAP, SET, JEE, NEET and other exams. Okay, so look at here, froth flotation. Okay, this method is mainly used to concentrate low grade sulfide ore. So what is the purpose of this froth flotation purification method? So this method is used to purify to concentrate low grade sulfide ores. Okay, right. And the next one here, let me explain. Yeah, so let me check everything is clear. Yeah, okay, and then next here, how do we do this process here? How do we do this purification method? Just see here, finely divided ore is suspended in water. So first of all, whatever the ore you wanted to purify here, so what we need to do, you need to crush it. Okay, so finely powdered ore is suspended in water, taken in a tank to form a slurry. Okay, so like you need to make like a slurry, like mixing that ore, powdered ore with the water, you need to make a slurry. Okay, now to this we need to add pine oil or olive oil, that is what collector, and a froth agent such as sodium ethyl xanthate is added. So first you take ore, okay, sulfide ore you take, so crush it, means you powder it, and then next add it to the water. After adding it to the water, it will be becoming slurry, right? To this slurry we need to add olive oil or pine oil. Okay, along with that we need to add frothing agents such as sodium ethyl xanthate. These things should be added to the above slurry. Okay, then after that we need to pass bubbles, like air is passed, so that air is bubbled. Okay, we need to pass air that will be bubbled here. So through the mixture, to this slurry mixture, after adding pine oil and this sodium ethyl xanthate, we need to pass air, so that it will be, air is bubbled through the mixture. So froth containing ore particles is formed. So what is happening? So froth, this froth containing ore particles is formed now. Now we are going to see some froth, like some bubble kind of things. Froth will be absorbed on the container, I mean on that slurry. Okay, now see here, the ore particles are there to the froth. Now what happens? Whatever the ore particles are there, that will be sticking, that is what, adhering to the froth, and that will comes up. Okay, now whatever the impurities will be there, that will be settled down. So look at here, ore particles are there to the froth while gangue particles settle down, that's it. Okay, this process works because mineral particles are wetted by oils, means minerals are wetted by oils, and gangue particles are wetted by this water. It means you are adding this pine oil, right? So with that pine oil, this whatever the mineral particles are there from that ore, the mineral particles will be adhered, or means sticking to the froth, and that will be coming up. Okay, and now whatever the gangue particles we have, impurities we have, so that will be settled down in the water. Okay, that's it. Okay, up to here it is clear. Now the froth is stabilized by cresol or aniline, and then it is skimmed off. So it means what? That whatever the froth is formed, in that froth now what we have, our mineral particles are there. So now we need to stabilize that froth, otherwise again it will be collapses or will be disappears from that, and it will be falls down into the like water itself. So what we need to do, we need to stabilize that froth formed right now. So for that formation, the stabilization of froth is by adding cresol or aniline, okay, and then it is skimmed off. Okay, then next, the collected froth is dried. to recover the ore. So now whatever the froth coming at the container, see, let me show you this, then you will feel it. Yeah. So look at this. So this is a setup. So now you can see here you have water part and this is the froth. See, mineral froth, it means this froth contains mineral, right? So now this whatever the top layer, this froth layer is there now, so that will be collected off. So after collecting off, we need to dry it so that whatever the mineral parts which are there in this adhere to this froth will be collected out. Okay, so this is what the froth flotation useful and application. Okay, hope everything is clear related to the froth flotation. Okay, now where it will be used, see, copper pyrite, this is iron pyrite, zinc blend, all these are what, like sulfide ores only now. See here copper pyrite, CuS is there. Okay, here zinc blend, ZnS is there, galena, PbS is there, all these are what, sulfur, like sulfide ores only, right? So this can be concentrated by this method. See, what you can remember, froth flotation is a method to use it to concentrate sulfide ores, to purify sulfide ores, or to concentrate sulfide ore from their low like are impure, from its impure ore form. Okay, that's it. Next example over the next note. If two sulfide ores are present, let us say we have taken a mixture which contains impurities along with our sulfide ores. Okay, and here multiple sulfide ores are there. For example, here in this whatever the mixture we have taken, we have impurities along with our zinc sulfide and PbS, that is lead sulfide and zinc sulfide are there along with some impurities there. Now we can remove lead sulfide, impurities normally by using this froth flotation. And now how can we separate zinc sulfide and lead sulfide here? Read this. If two sulfide ores are present, occur together, then dip presents like NaCN, like in sodium cyanide, are added to prevent one ore to form frothing form. It means out of this two, only one will form froth, another will not form. So for this purpose what we are adding, NaCN, that is sodium cyanide is added, so that only one will be purified first, then later the other. Okay, like that we can use this froth flotation process. Okay, right. So you can represent this image also beside your explanation, so that yes, like whoever correcting your paper will consider that yes, this person is knowing the concept clearly. Okay, you need to present it very clearly, then you will get maximum score. Okay, this is for 4 marks question in your IPE second year syllabus, right? Okay, and that whatever the froth flotation question we discussed, it is asked multiple times. Please focus on that. Okay, the next important question here we have is, give examples to differentiate roasting and calcination. So what do we mean by roasting and calcination here? See, these are the terms we will be using in our daily life also. For example, roasting in means what? We will be using in our daily life while cooking also. See, heating of ore in presence of oxygen. Okay, so it means you are taking an ore, you are heating it in presence of excess of air, that is excess of oxygen. Here you can say with the supply of oxygen. See, ore is getting oxidized. See, it's very simple. Now whatever the ore is there, that will be converted into its oxide form. Okay, so how it will be converting? So it will be converted into the oxide form. See, heating of ore in presence of oxygen, ore is oxidized, okay, and like ore is oxidized to oxide form, whereas volatile impurities are there now, that will be removed off here. Okay, for example, it is used for sulfide ores. See here, zinc sulfide is there. So now what I required here, I required to extract, give me a okay, look at here. So ore is oxidized to oxide, while whereas volatile impurities are removed here. Okay, so now see here we have zinc sulfide here. Zinc sulfide is heated with oxygen. Now what happening? Whatever the zinc metal is there here in the sulfide, zinc sulfide, so that will be converted into respect to oxide forms. See, zinc sulfide converting into zinc oxide, lead sulfide converting into lead oxide, like this. Okay, now here sulfur is there now, so that will be So sulfur is there, that will be converted into its oxide form, sulfur dioxide. Okay, see, volatile impurities are removed. See, these are gases now, so this will be removed off. So we are getting oxides and sulfur dioxide will be removed off. So we can collect our metals from their ores in the form of their oxides. Remember this, we are forming, we are getting oxide forms. Okay, then next, when it comes to calcination, see, heating of ore in absence of air. So what is the difference? Here it in presence of air, calcination means in absence of air. So now what happens here? Check here, volatile impurities removed. So whatever we have volatile impurities, that will be removed. So ore becomes porous. Okay, for example, here you can see calcium carbonate, like a solid mass we will be seeing now. So this calcium carbonate, upon heating, what happens? It will form calcium oxide and CO2 gas will be removed out here right now. So now see here, this calcination particularly used for carbonate and bicarbonate ores. For what purpose? For carbonate and bicarbonate ores. Okay, so you can see here zinc carbonate is there, calcium carbonate, zinc carbonate. Upon heating, CO2 gas will comes out and respective oxides will be formed here. Okay, so remember this calcination most like frequently used for what purpose? So for carbonate ores and bicarbonate ores, because upon heating in absence of air, these carbonates and bicarbonates decomposes to respective carbon dioxide plus oxide form. See, calcium carbonate gives calcium oxide plus carbon dioxide, like that. Okay, so in short, you just remember these two terms, roasting in presence of air, that forms oxides. What do we mean by roasting? So this will be heating of or in presence of air, that forms oxide. The next, calcination, there is absence of air, so that will be giving you CO2 gas out, like CO2 gas is removed out, so that you will get respective oxide forms of the metal. Okay, next one is explain about extraction of zinc from zinc blende. So what do we mean by zinc blende here? ZNS right now. So ZNS will be used, this is a ore from which we are extracting zinc. Okay, so read this question, read this statement here. The raw material used for extracting zinc is zinc blende, okay, or zinc sulfide. Zinc blende is also called as zinc sulfide. So the extraction of zinc from zinc blende, we are following this many steps. See here, first step is concentration of ore. Okay, so see here, we can do concentration of ore by froth flotation. Why? Because see, zinc blende is nothing but zinc sulfide ore only, no? Like sulfide ore only, no? So the first question itself we have learned, whenever there is a sulfide ore, we can concentrate it using froth flotation right now. So the zinc blende, that is what the zinc blende, ZNS, O is crushed and concentrated by gravity separation first, and then by froth flotation. So here we can use froth flotation process for concentrating it. Okay, first crush the zinc blende, then next you can concentrate using gravity separation method, and then followed by froth flotation process. Okay, as it is a sulfide ore. Okay, this is important point to be mentioned. Okay, then next, this removes impurities such as silica and earthy matter. Okay, wherever if it is having any sand or anything like that, that can be removed off here with the help of these two methods. First crush the zinc ore, okay, zinc sulfide ore, then after that use the gravity separation method to concentrate, and followed by froth flotation method. These are the two things to concentrate the sulfide ore. Okay, the next method is what? Roasting here. So what do we do in the roasting method? See, the concentrated zinc sulfide ore is heated in presence of oxide, mean oxygen. Okay, so just now we have studied roasting, right? So roasting means what? Zinc sulfide will be heated in presence of oxygen. Okay, now what happens? Zinc sulfide is zinc oxide is formed here. Okay, see here, zinc sulfide with oxygen heating at high temperature like 1100 Kelvin, forming zinc oxide plus SO2 gases goes out of here. Okay, so that's it. Zinc blende converting into zinc oxide, and sulfur dioxide is removed from here. So now what is the purpose of doing this method here? So it removes the volatile impurities like sulfur. Yes, sulfur is converted into sulfur dioxide, no? So like that, sulfur, arsenic, etc., whatever the impurities are there can be removed here. Whatever the volatile impurities are there, that can be removed in this process. Concentrated sulfide, zinc sulfide ore is heated in presence of excess air, that removes volatile impurities. The next method is reduction. So what is the use of doing this reduction? See, in the above concentration what we got here, see zinc oxide is we got now. So but what we required zinc metals. What we required? Zinc metals now. So zinc oxide should be converted into zinc metal. It means that oxygen must be removed from this zinc oxide, right? So for that process we can use a reduction. What do we mean by reduction? It's a basic definition we have now. Removal of oxygen is called a reduction. So we need to remove this oxygen so that our zinc will be formed over here. So just see, zinc oxide, the zinc oxide obtained is mixed with powdered coke. So whatever zinc oxide we got, that should be mixed with powdered ore and then heated in a fine clay retard, okay, and then we need to heat this zinc oxide plus like powdered copper coke is there. Now we need to mix that, okay, just a minute. Okay. So now what I am saying here, zinc oxide should be treated with carbon. So this will be heated at 1673 Kelvin. Now what happening? So whatever the oxide form is there, that will be converted into zinc. So what is this process? See, removal of oxygen from zinc, zinc oxide converting into zinc. So it is a reduction process only now. So that this method is used for preparation of what? I mean reduction of what? Zinc oxide, so that we will get a zinc metal here, okay, and CO gas will be removed here, that is it, okay. So what is the process called? This process is called as Belgian method of reduction. So what do we mean by Belgian method of reduction? So zinc oxide plus coke, that is carbon, okay, heated, that will be giving you zinc plus carbon monoxide, that is it, okay, remember this point. Okay, zinc oxide converting into zinc plus carbon monoxide. So result, zinc metal is produced in vapor form and condensed to the liquid. So whatever the zinc here we are getting, that will be in the vapor forms. Okay, so it means what? We are heating at 1673 Kelvin, right? So this is a very high temperature. So it means whatever zinc form is there here, that will be in the vapor state. So upon condensation, means upon cooling down, it will be converts into liquid like that. Then after that it will be solidified. Okay, the next, see, purification, last method. Crude zinc contains impurities like impurities. There will be some impurities here, okay, small amounts of cadmium, iron, lead will be there. So that will be purified by fractional distillation or electrolytic refining. So what method we can use? By fractional distillation or by electrolytic refining, we can remove out this cadmium, iron, lead from this zinc impurities during the zinc purification, that is it. Okay. Now what are the methods we have? Tell me. First you take a zinc sulfide ore, then powdered it, crush it, then next use gravity separation method, okay, after that followed by froth flotation method. So by these methods we can concentrate our zinc sulfide ore, okay. After concentrating the zinc sulfide ore, just subject it to roasting. Roasting means what? Zinc sulfide is heated in presence of excess oxygen. So now what happens? Zinc sulfide will be converts into zinc oxide and sulfur dioxide gas will be removed off from here, okay, that's it. Now we got our zinc oxide now. So zinc oxide now treated with coke, it means reduction process we are using. So coke means carbon plus zinc oxide. So together undergoes, I mean reaction gives a reduction product of zinc, okay, like zinc metal is formed and carbon monoxide gas is released. Okay. Now zinc oxide is converted into zinc, right? Okay. Along with our zinc metal during this reduction process, there will be some small quantity of impurities like cadmium, iron. See, cadmium, iron and lead are the impurities. So this will be removed by what method? So this will be removed by two methods. It can be purified by either fractional distillation or by electrolytic refining. That's it. Okay. So this is about the thing. Okay, the next, how do you do electrolysis? Means, see at anode zinc will undergo oxidation, at cathode zinc will undergo reduction. So pure zinc, see, it means this is very easy, I will tell you. Electrolysis process, you might be aware that you have studied in electrochemistry chapter. If not, just listen to me, I will explain you very clearly what is happening here. Yes, see, this is a container in which electrolysis is taking place. So electrolysis means, tell me, is it a spontaneous process or non-spontaneous process? It's a non-spontaneous process. It means we will use external battery here. So we will be using some external battery source here. Let me write. Okay, like this I am taking. Okay, this is positive sign, you can say. This is anode, you can say. Anode this side, and this side is cathode. Okay, you take it like this. Now what? See, this is nothing, like you no need of representing this during the exam, but I just wanted to add up so that you can remember the remaining part also. Okay, so see here, cathode we have anode there. Okay, so cathode is a negative part. So cathode is negatively charged electrode now, so it means it will attract opposite charge ions. See, it is negative charged means it will attract all cations. Okay, cathode means the electrode which attracts cation. Anode means it is a positive. So anode is an electrode which attracts anions because it is a positively charged species. Anode means it's a metal rod which is a positively charged one. Okay, that will attract what? Anode attracts anion, cathode attracts cation. You just remember in this way. Okay, now what happens? Tell me here. See, at anode, always remember, at anode oxidation is taking place. Okay, now what I am doing is I am using, see, there is some impurities along with our zinc. What happens? There will be some impurities like this now. So whatever the zinc, that impure zinc is there, you take it as a anode. So what is this anode now here? So along with your zinc, there are some impure zinc I am writing, zinc impure form. So impure metal form here I am taking, impure zinc form here I am taking. Now what happens when I pass electricity? Now whatever the zinc here it is there, impure zinc is there now. So from these impurities will remain here only, but whatever the zinc is there, only just zinc is there, that will get oxidizes to zinc plus 2. Okay, so now zinc plus 2 and 2 electrons are released here. Now whatever the zinc ions are releasing from here, so now what happens, all that Zn plus 2 ions, see, this is Zn plus 2 now, this plus 2 ion is forming now, so that will be attracted by our cathode, because cathode is negatively charged electrode, right? So all these zinc plus 2 ions will move towards cathode. So at cathode what happens is, all these Zn plus 2 ions that are coming from this anode electrode, okay, because anode electrode is an impure form, it contains zinc as well as some impurities. Now impurities will stay here only zinc metal is undergoing oxidation and converting into Zn plus 2 ions. Okay, slowly whatever the zinc is there here, completely coming into this solution. Okay, that solution, that zinc plus 2 ions will be going towards this cathode. So at this cathode, now reduction takes place. So whatever the zinc ions came here to the cathode, that will be converting into zinc metal. Okay, so this is how we will purify. So this is an impure form giving a pure zinc metal. We are getting a pure zinc metal. So this is how we are using electrolytic refining, one of the very important method to purify the metals, like electrolytic refining method we will be saying. Okay, right. Is this clear or not? Yes. Similarly, we can also purify silver also. Okay, so that is not required, but you got this concept now. Yes, this is very important. So pure form of zinc, where we can collect it at the cathode, and impure form of zinc will be presented where? Anode. That's it. See, pure zinc is deposited on the cathode. Yes, all the zinc ions will be deposited on this rod. Okay, that's it. So I hope the discussion of this electrolytic refining is very clear without having any confusions, right? Okay, so try to remember these two questions that we have discussed till now. One is froth flotation, and the second question is difference between roasting and calcination, a small question. After that, we have discussed about explain the extraction of zinc from its zinc blend, that is zinc sulfide ore. Okay, 3 questions are done. The next 4th question is here we have. Yes, so see here, see, outline the principle of refining of metal by following method. See, just now I clearly explained about electrolytic refining. Okay, electrolytic refining is clearly discussed just now by drawing the image and all right now. So first look at this zone refining. What is this zone refining? See, zone refining is based on the principle that the impurities are more soluble in molten metal than in the solid metal. Okay, see, zone refining, it means we are using different we will be using high temperature zone here. Okay, so using that we will be purifying this. See what they are saying, based on principle that impurities are more soluble in molten metal than in the solid metal. Okay, it means we are using a movable heater. What we are using? We are using a movable heater that melts a narrow zone which carries impurities to the one end. Okay, it means this is very simple, ma. Okay, let me show you the diagram itself here in the book. So guys, see whatever the book I am showing you here, this booklet, why I am only explaining on from this booklet, why I am not using any PowerPoint presentations or normal board here, because you can access this free material from our NEET World app. Okay, so this is our IPE material, okay, designed to score 60 out of 60 in your IPE exam, whether it can be class 11th or class 12th students. Yes, for all these Telugu state students who are going to write this IPE exams now can access this material for free of cost. Okay, now how can you access this material? Yes, just go to Play Store and download our NEET World app. Okay, so in this NEET World app, you just go to the chart section and just say IPE books or just say hi, so that our team will respond to that and they will guide you how to access this material for free of cost in the app itself. Okay, yes, then you can download them and you can utilize them for your preparation, for your IPE preparation. That's it. Okay, yes, not only chemistry, so the same material, like similar material will be there for your physics as well as biology, biology for BPC students, mathematics for MPC students, both Maths A 1A and 1B, 2A and 2B, everything will be provided in the app. Okay, so just go to the app once, then you will get to know how can you access all these things. Okay, right. Is there any doubts in the discussion? Tell me. So is there any doubts in the discussion? Tell me, who are in the live session. Yeah, if no doubts, let us move forward for few more questions here, right. So we are discussing about this electrolytic refining, right. Electrolytic refining is over, zone refining we are discussing about, right. Yeah, let me show you one image first so that you will get some clarity on this. Yeah, so look at here, I have a separate question for zone refining, that's why I am opening this. See, what do we mean by zone refining? Zone refining is a method of purification used to obtain metals of very high purity. So this method is used to obtain purify with a very high purity form. Okay, such as silicon, germanium, gallium, indium will be used here. Okay, so look at this definition. Zone refining is a method of purification used to obtain metals of very high purity such as silicon, germanium, gallium and indium. So what is the principle involved here? The solubility of impurities is more in molten metal than in solid state. Okay, it means, see, this is a like a rod we are taking. Okay, so let us say this is an impure germanium rod. What we are saying, this is an impure germanium rod. Now what I am doing is I am passing a heater, circular heater I am using. See, this reddish golden yellow color is there now. So this golden yellow color part is what? It's a circular heater. Okay, so this circular heater we are passing through this rod, this germanium, impure germanium rod. Now what happens whenever you are heating this rod at one end? Now what happens? Whatever the impurities are there in this germanium rod, all will come towards this molten form of this impure germanium rod. Why? Because here whatever the impurities present in this rod will be having more solubility in molten state compared with the solid state. Okay, that's why all the impurities of this germanium rod will come closer and that will be comes into this molten form. Okay, so now that will be taken out to the one end. So now what happens, the impurities from all the sides will be brought to the one end of this rod. Okay, so how it will be brought? Yes, we will be starting like this. Yes, we will be bringing that heater like this. So now what happens, that impurities comes along with the heater to the one end of this germanium rod. Okay, so now what is happening here, molten zone containing impurities. Yes, see circular heater, see the direction of travel of heater, so the molten zone and impurities. Yes, so when we pass this heater from this end to this end, what happens, we are starting heater at here. So now what happens, so whatever the impurities are there, yes, slowly converting into coming into this molten form. Like this we will be taking this heater from this end to this end. Now what happens, so at this end we will be seeing impure form of, like impurities of whatever the impurities present in this zinc, this germanium rod will be coming at here. So here you can see recrystallized pure germanium. Yes, so this side we will be having pure germanium because all impurities are taken up to the one end. Okay, that's it. Okay, hope this concept is clear. See here, the solubility of impurities in more in molten metal than in solid state. This is the main principle to be remembered whenever you are thinking about zone refining. So what is zone refining? Zone, it is a hot zone, you can remember. So in the hot zone, impurities will dissolve more or soluble more when we compare with the solid substance. Okay, hot zone is nothing but here a molten state, molten zone here. Okay, that's it, metal in the molten form, that's it. Okay, so a circular induction coil is circular induction coil heater is placed at one end of the impure metal rod. Okay, the heater moves slowly along the rod. Okay, along the rod, okay, forming a narrow molten zone. So forming a narrow molten zone. Okay, the molten zone moves forward carrying impurities along with it. Yes, whatever impurities are there, that will be carried by this molten zone. Okay, the metal behind solidifies as a pure metal. Okay, this side now it will be pure if we move this heater that side. Okay, the process is repeated several times to obtain highly pure metal. So the same process will be repeated so that we will get more high purity metal. Okay, that's it. This is how we will be doing zone refining. That's it. Okay, right. Next question here is, yeah, so electrolytic refining, just now I told you about this electrolytic refining before this question. See, it is used for less reactive metals like copper, silver, like iron, like gold, aluminum, etc. Okay, so now what we are doing, I just told you by drawing the diagram. So impure form of that metal will be taken as anode, pure form will be taken as cathode. Now what happens, whatever the impure form of metal is there, that will be undergoing oxidation and that will be converting into electrolytic solution and slowly moves to the cathode. So at cathode what happens, reduction takes place. So all that metal ions will get deposited onto the cathode by undergoing reduction. Okay, so this is how we will be doing. So pure metal deposit on cathode, impure collects as an anode mud. So now all the impure form, like impure form of metal will be taking it anode, right? Now whatever that metal is there, like normal whatever the purified metal we wanted to take, now that will goes to the cathode side. Now impure form will fall at the bottom of that anode electrode. Okay, so that is considered to be anode mud. What we can say, that is an anode mud, that's it. Okay, the next one is, what do we mean by pooling? So pooling is a process in which we will be taking a normal green pole, like a green wood. See here you can see, based on the principle that metal contains their own oxides as impurities. See, there are some metals, for example, see, we know when you take some ores, what happens, most of the metals in their oxide forms right now. So metal will be there and some oxide form will be there. See, it is based on the principle that metals contains their own oxides as impurities. Okay, metal and some impurities along with the metal are in the oxide form. Okay, so now what we are doing, the molten metal is stirred with green wood poles. Okay, so we know these green wood poles are nothing but carbon only, na, that it contains carbon content only, na, like green like plant woods you are taking means that will be normally what, it is a carbon content only, right, organic matter only. So now what happens, whatever the impure oxides are there, so the oxides are reduced to metal form. okay, oxides are reduced to metal form, whereas the carbon of these greenwood poles will be converting into carbon monoxide, carbon dioxide gases which escapes from that. Okay, so this is used for copper and tin refining. So this poling is a method used for copper and tin refining. So what we will be doing here, if along with the copper metal, if there is any copper oxide forms are there as an impurities, we need to convert this copper oxide forms, or we need to remove this copper oxide forms now. So what we are doing, yes, we are melting it first. We are taking molten form of this impure mixture, okay, and we are stirring it with the greenwood poles. Okay, now what happens, now whatever the carbon content we have in the greenwood poles will undergoes oxidation and reduces our copper oxide to copper metal. Okay, so that we will get complete pure metal, copper metal, and CO2 and CO carbon monoxide gases will be formed from these greenwood poles, okay, and that will be escapes from that. So this is how we can be purify that. Okay, the next method is vapor phase refining. So look at this, what do we mean by vapor phase refining? In this method, metal is converted into volatile compound and then decomposed to get a pure metal. So vapor phase refining means what? In this method, metal is converted into its volatile compound, okay, and then decomposed to get the pure metal. Okay, it will be converting into volatile compound first, then we will be decomposing it to get a pure metal. Okay, so you can see here metal should form a volatile agents with available reagents. Okay, we will be using some specific reagents, okay, with help of that specific reagents. Now whatever the metal we want to purify, that will form a volatile compound. Okay, when it is forming volatile compound, that volatile gas will be separated out. Okay, we are extracting that volatile gas. Now extracted volatile gas upon decomposition gives our pure metal, that's it. Okay, see, the metal should form a volatile agent with the available reagent. Then next, volatile compound should be easily decomposed to recover. These are the two conditions to be followed here in the vapor phase refining by the metal. Okay, then only we can use that method, that's it. Okay, this is about vapor phase refining. Okay, so it's very easy. Try to remember or try to understand each and every sentence. Zone refining means what? Yes, whenever they say zone refining, yes, there is a coil heater which is a circular coil we are taking to maintain this molten form of that metal, like it will be used like germanium, gallium, for this kind of metals we will be using. So by moving that coil, the impurities will also move along with the molten state. Like that, everything vapor phase means, yes, that metal should undergo or it should form a volatile compound whenever we are treating with a suitable reagent. Okay, now once after forming this volatile compound, yes, that volatile substance will be separated out. Now after separating this volatile compound, that should that whatever the separated compound is there, now volatile compound, it should easily undergo decomposition to give our pure metal. Okay, so this is how we will be using vapor phase refining, that's it. So this is how you just make your own generalized words or statements in your mind. Okay, you just create your own sentences in your mind whenever you listen to a term like vapor phase. Yes, these are the steps to be remembered. Okay, zone refining, these are the steps to be remembered. Froth flotation, yes, these are the steps to be remembered. So take sulfide ores, crush sheet, like whatever the steps are there, you just follow them and make in your mind, just make like a flow chart. Okay, so that it will be clear and you should not need to remember them or you need to by heart them. Okay, nothing, just understand the concept. It will be utilizes all the time, whether you are writing just a descriptive type exams like IPE or such exams, or you are going for any competitive exams like EAP set, because in JEE we do not have, JEE mains or NEET we do not have metallurgy. But anyways, this, if you learn the concept, definitely that will be useful. Okay, right now, so for JEE advanced you can expect, or in EAP set we have. So that's why, yeah, try to understand the concept instead of by hearting them, right. The next here we have explain briefly the extraction of aluminium from bauxite. So how do we extract aluminium from bauxite? See, the extraction of aluminium from bauxite involve three main steps. The first step is purification of bauxite. Okay, so purification of bauxite, that process is called leaching. What we are saying, leaching or Bayer's process here. So bauxite ore. So bauxite ore is nothing but Al2O3 dot XH2O. So this bauxite ore contains impurities like iron oxide Fe2O3 and silicon dioxide SiO2. Okay. Bauxite ore will be there, Al2O3 dot XH2O, along with that some impurities like Fe2O3 or SiO2 will be present right now. So the finely powdered bauxite is digested with caustic soda. What is caustic soda? It's a NaOH only. So first crush that bauxite ore, powdered form of bauxite ore you can take, and just mix it with the caustic soda, NaOH. That process is called digestion. Okay, at what temperature? 473 to 573 Kelvin and 35 to 36 bar pressure. Okay, now what happens? This bauxite containing Al2O3 now, so that will be digested with NaOH, forms sodium aluminate. What it is forming? Sodium aluminate. See here what they are saying, the solution contains sodium aluminate and impurities remains as insoluble residue. See, we have a bauxite ore along with these impurities right now. So I want only aluminium here. I do not want these impurities. We need to remove this right now. So for that process what we are doing? First crushing like powder, and that will be digested with NaOH. So during this digestion what happens is only Al2O3 will react with the NaOH and forms sodium aluminate. Like this iron oxide and silicon dioxide remains impurities, like remains insoluble. So now what we can do, this whatever the solution from is there, whatever the aluminium we required, all aluminium like Al2O3 converted into solution form right now. So now this will be taken out. Okay, so now what we are taking out, this will be taken out. So SO2 gas is then passed to precipitate hydrated aluminum oxide. So whatever the solution we have collected, so through that CO2 gas is passed. Which gas? Carbon dioxide is passed. So now again we are going to get our Al2O3 dot XH2O. So this is now our pure form because these impurities were removed out. Okay, because these are insoluble, right? So that will be separated out. Okay, the precipitate is then filtered. Now precipitate contains Al2O3 dot XH2O. Now the precipitate is filtered, washed, dried and heated at 1470 Kelvin. So we are heating at this 1470 Kelvin to obtain our pure alumina. So Al2O3 dot XH2O is there now. So this XH2O is removed at 1470 Kelvin. So you will get pure Al2O3. This is called alumina. Al2O3 is called alumina. So the next method here you can see electrolytic reduction of aluminium. Okay, what is the next method here? Electrolytic reduction of aluminium by Hell-Horrall's process. What is this Hell-Horrall's process? See here, pure alumina cannot be electrolyzed directly. What I am saying, this pure alumina cannot be electrolyzed directly because it has very high melting point. Okay, so during electrolysis we should contain it in the molten form, like a liquid state material it should be. Okay, then it can be purified here, I mean electrolyzed here. See, pure alumina cannot be electrolyzed directly because it has very high melting point. Okay, now what we need to do, we need to decrease the melting point of alumina right now. So for that purpose, see here, it is dissolved in molten cryolite. What is the formula of cryolite? Na3AlF6. Now there is a question, previously asked a question, like they will say match like list 1, list 2. Okay, we need to match the list 1 components with the respective list 2, which are suitable options are there. We need to answer based on that. Yes, this kind of questions are very frequent in your EAP set and JEE exams. Okay, please try to understand what is this cryolite formula, Na2AlF6. Okay, and the next fluorspar is it. So fluorspar means calcium fluoride. Okay, so what is the use of calcium fluoride here? To lower the melting point of alumina. So it will lower the melting point of alumina. Therefore when it is lowering the melting point, yes, it will be now in the molten form and its conductivity will be increased. Okay, that's it. Okay, it is dissolved in the, see, pure alumina will be dissolved in the molten cryolite and fluorspar. So now what happens, the melting point of alumina will be reduced and also that increases the conductivity here. Okay, the electrolytic cell has carbon electrodes and molten alumina cryolite bath. Okay, so now in the electrolytic cell what we have, carbon electrodes will be there and in which this alumina cryolite bath will be there. okay, reaction. So at cathode what is happening, reduction takes place, whatever may be the process, at cathode reduction takes place. Okay, so see at cathode alumina Al plus 3 ion from alumina getting converted into Al, so our metal is forming, right? So at cathode, and at anode whatever the carbon is there, that will be converting into carbon dioxide. So this is what HH, Hull-Holtz process. Okay, that's it. The next one is, so you can collect your molten aluminium at the bottom during the process, that's it. The next one is what, purification of aluminium by electrolytic refining. So electrolytic refining, just now we discussed previous to this. So just listen here. So there is an iron tank lined with a carbon. Okay, iron tank will be there, that is lined with a carbon, that is acting as a cathode. Mostly here carbon act as a cathode here. Okay, and graphite, see both of them are carbon content only, but you can remember iron tank lined with the carbon act as cathode, whereas graphite rods act as anode. Okay, the cell has 3 layers. Okay, in this cell for purification of aluminium electrolytic refining is used now. So in this cell we have 3 layers. Okay, 3 layers are there. So the top layer is pure aluminium plus graphite. Okay, graphite means it is a cathode here, this one. Okay, because iron tank is lined with carbon now, so that is nothing but our cathode. Okay, middle layer contains molten fluorides like AlF3, BaF2, NaF is there. Okay, and at the bottom portion we have impure aluminium. Okay, so this impure aluminium can be purified here during this electrolytic refining. So on electrolysis, aluminium ions migrate upwards and deposit as a pure aluminium. So this impure aluminium is there now at the bottom. Okay, so that will be flows up, that will travels upside. Okay, so finally at cathode reduction takes place and gives you pure aluminium. So on electrolysis, aluminium ions get migrated upwards and deposit as pure aluminium at the cathode, that's it. Okay, so final product is what, high purity metal, aluminium metal is formed. Already we discussed about this zone refining, that's done. And one last question from metallurgy 4 marks is, write any 2 ores with a formula of the following metals. Okay, these are the 4 metals we have, we need to write their ores. Okay, and you know this box here whatever we are seeing, it is equally important for your any exam, JEE, NEET, EAP set. Okay, because these questions, like you are studying this about this in your 10th class itself. See what are the ores we have and what are their formulas. See, for example, see here for aluminium we have bauxite ore, just now we have seen, along with the bauxite we have calconite here. Okay, just read this statement, the composition of a metal ore is essential in metallurgy. Here are 2 important ores that their chemical formula for each ore is specified here. Just see, for aluminium we have bauxite Al2O3.2H2O, and for this we have Al2O3.SiO2 and 2H2O. These are the 2 formulas and their names to be remembered, ore names and ore formulas to be mentioned during the exam. For zinc we have zinc blend, ZNS. Yes, ZNS we have seen, ZNS is one of the major ore for extraction of zinc right now, zinc sulfate, that is zinc blend is one of the major ore for extraction of zinc metal. Okay, next one is calamine, zinc carbonate. See this carbonate ores like calcium carbonate will be there, and the next iron carbonate FeO3 is there. They will ask now what is the following is a formula for calamine or seed, right? Like that they will give some names and they will ask us. See, calamine, zinc carbonate. Okay, for iron we have hematite ore. What is the formula of hematite? Fe2O3. Okay, Fe2O3 is a hematite formula. Now what about siderite? Siderite is FeCO3. So this is the JEE mains question previously asked. See, we are studying about IPE classes only, now this is IPE session only, but here we have these ores, these compositions are directly asked in the JEE exam also. It's very important, you try to remember this table. Okay, so siderite ore is calcium carbonate, calamine ore, what is this? Zinc, like siderite ore is iron carbonate, FeCO3, and calamine is zinc carbonate, ZnCO3. Okay, copper we have copper pyrites. What is the formula of copper pyrites? So CuFeS2, FeS2 is our copper pyrite. Next one is malachite. Okay, malachite means what? Copper carbonate dot copper hydroxide. CuCO3 dot CuOH twice is a malachite. Okay, remember copper pyrite is copper FeS2 and siderite FeCO3, calamine ZnCO3. Okay, the next here hematite Fe2O3. Like this, try to remember this table. It will be equally useful for your competitive exams along with your IPE exam. Okay, so thanks for watching. I hope you are really followed the session, and if there is any confusion or any doubt you have in this, please mention in the chat box. We will be discussing them in the chat box itself. Okay, I will be definitely replying based on your question. Okay, right. And if you have any concern, please mention there, and you can share these sessions with your friends who are preparing for IPE exams. Okay, and you know whether your junior students who are there, for example, the students like your juniors are now class 11th, right? So for them also we are doing IPE free live sessions here. So you just share with them, they can also use these sessions and it will be very helpful for them. Okay, and one more thing, if you are preparing for EAP set, yes, you can join our free live sessions. Those are also conducted every day in this NEET World YouTube channel only. You just join them and make your preparation more effective and more productive. So thanks for watching. Stay connected with us. Thank you.